Welcome back, everyone. It's your boy Subpar Math Kid, bringing you another project video. To start off, I just want to thank all my subs. You guys mean everything to me. I love you guys. To start off, let's get ourselves a nice juicy stat meme. Then this will be our hook that engages the viewer. I repeat, this is the hook that engages the viewer. So here we have Dwight going, about 76% of statistics are made up on the spot. And then below it goes, actually, 77.4% are. Isn't that some funny stuff? Oh my god. So today, in our calculus video project, we're going to be talking about topic 5.4. In topic 5.4, we will be covering linear correlations, Pearson's product, moment correlation coefficient R, scatter diagrams, lines of best fit, equation of regression line of y on x, use of equation for prediction purpose, and mathematical and contextual interpretations. This is topic 5.4. Video project by Elijah Wall. Let's begin. Now, before we begin any problems, I would like to address some things. Let's begin with the R value. Now, when we're talking about 5.4 and the R value, as you can see in the top left corner, when the R value is around 0, you're probably going to see a scatter plot that looks kind of like this. There is no correlation. So the closer a number is to 0, the weaker the correlation is. Moving on, as we see in this quadrant, the R value is closer to -1. The scatter plot and graph or table should look something like this. When the R is closer to -1, it means that as one value increases, the other decreases. In this case, as x increases, y decreases. Finally, in this quadrant here, we see the opposite. As r is closer to 1, as the x increases, as does the y. Now, keeping that in mind, to recap, when the r value is 0, there is no correlation. When the R value is close to -1, there is strong negative correlation. When it's close to +1, there is strong positive correlation. Now bear in mind that the R value is in between -1 and 1. Now let's say, for instance, you have a R value of, let's say 0.2. This would be a positive correlation, but in comparison to 0.99 repeated, it would be considered weak positive correlation. And the same thing could be said on the other side of -0.2. Now that we have that out of the way, we can do some math. Oh, by the way, before I forget, there's this big long equation that is used to find the R value, but IB doesn't really care, so neither do we. Most of the problems that we'll be doing are through the use of a calculator. So you really don't need to do it by hand, which is pretty nice. Okay, now back to math. Alright, let's get it. Problem 1a. Jim heated a liquid until it boiled. He measured the temperature of the liquid as it cooled. The following table shows its temperature, D degrees Celsius, T minutes after it boiled. So, as we see, we're presented a situation and we are given a table to go along with it. 1a asks, write down the independent variable. Now, upon a quick glance, it might seem that what we're measuring is time, as usually we do measure time, but in this case, if we look closely, he measured the temperature of the liquid as it cooled. So our independent variable is time, and our dependent, what we're measuring, is going to be temperature in degrees Celsius. So your answer will be time, of course labeling in minutes. Moving on. The second question asks, write down the boiling temperature of the liquid. Now, your first instinct might be to say, perhaps, well, Elijah, I'm from the United States. I don't know Celsius. I don't know the boiling temperature. What the heck? Well, upon further investigation, as we reread the problem, Jim heated a liquid until it boiled. This first sentence, we know that he heated the liquid until it boiled. So, at t minutes 0, the temperature is 105 degrees Celsius, meaning that at 105 degrees Celsius, the liquid will boil. Again, be sure to write 105 degrees Celsius and use your labels because you will get docked if you do not. Moving on to 1C, it goes, Jim believes that the relationship between D and T can be modeled by a linear regression equation. Jim describes the correlation as very strong. Circle that right there. And the question asks, circle the value below which best represents the correlation coefficient. Now, when we first look at it, we think, very strong. But Elijah, that's not what you said in the beginning. You said it's strongly correlated or weakly correlated or no correlation or positive correlation. Well, here we got very strong. So what that tells us is that it's either really close to 1 or really close to -1. So with that in mind, we can eliminate all these other options. When we look back at the table, we then see that our x and y, so as our x increases to 0 to 4 to 8 to 12, our y decreases 105, 98.4, 85.4, 74.8. So if we go back to the introduction where I explain this, you know that as x went up and y went down, this would be a negative correlation. So yes, both of these are very strong, but in this case scenario, this is the answer because there is a strong negative correlation. Moving on, the next question asks, Jim's model is -2.24t plus 105, for t is greater than or equal to 0 and less than or equal to 20. Use this model to predict the decrease in temperature for any 2-minute intervals. So, this is where our calculators come in. Bust out your calculators, go into the graphing section, type in this equation, -2.24x plus 105, graph that bad boy. Any minute now. If you can't see it, zoom 0, zoom fit, and there it is. As you can see, there's a clear negative correlation. Now what we can do is go to second table, and here we have values. So what can we do? What we find is that for every 2 minutes there should be a change. So let's go to the point at 4 minutes. Y equals 96.04, and at 2 minutes y equals 100.52. Now, if we take these values, 100.52 minus 96.04, we get the answer of 4.48. So, what does this tell us? This tells us that every 2 minutes from the time 0, the temperature in Celsius should go down 4.48 degrees Celsius. And therefore, this right here should be our answer. Okay, moving on to the second problem, it goes, the maximum temperature, T, in degrees Celsius in a park on 6 randomly selected days is shown in the following table. The table also shows the numbers of visitors, N, to the park on each of those 6 days. The relationship between the variables can be modeled by the regression equation n equals at plus b. Find the value of a and b. Now, first we want to see that n equals at plus b is simply y equals mx plus b. Now, with this in mind, it's pretty simple. First step is to enter all your data into lines 1 and 2 for respectively x and y. What you want to do is click Stat, Edit, and you want to enter all your x values into line 1, all your y values into line 2. Once you have done such, you then press Stat again, scroll right to Calc, go down to number 4, Linear Regression. Press Enter, scroll down to Calculate, enter again, and there it is, our A and our B. I personally would write these all out because these are numbers that we are going to use again in the future. Now, one thing you may have noticed when you perform this is that you have your y, your a, and your b, yet there is no r in r squared, and yet there should be. This here is a simple mistake and a quick fix. So what you first want to do is you want to go second, 0 to catalog, and then you basically scroll down. To get there faster, I would say press the matrix or D. By doing so, you then scroll down to Diagnostics On. Press Enter, enter again, it'll say Done. Now, if you go to Stats, Calc, Linear Regression, go down to Calculate, you'll see now that there is an r squared and r value. Now the question asks, write down the r value. Wow, isn't this is convenient? This is nice. This is really nice. So what you want to do is exactly that. Write down the r value. So finally, the last question asks, use the regression equation to estimate the number of visitors on a day when the maximum temperature is at 15 degrees Celsius. Now, as we know, temperature in Celsius and degrees is our x, and our number of visitors is y. So with that in mind, we're trying to find y. Y equals, and using this equation here, we know our a. So yes, it's long, but what you want to do is write it out again, just for good measures, times, then we substitute the 15 in, plus our b, and then from here, we simply solve for y. Now, when you complete these calculations, what you should get is y equals 32.2. Now, bear in mind, you obviously need labels, so 32.2 what? And that is number of visitors. This gives us a problem, though, because you can't have 0.2 visitors. That makes no sense. So then we have to round down. So our y should actually equal 32 visitors when the maximum temperature is 15 degrees Celsius, according to our regression equation that we created. Good. Alright, boys and girls, here's your homework. If you can't see it very well, I'll read it to you. It goes, the following table shows the average weights given heights and population of men, with weight being in kilograms and height being in centimeters. The relationship between the variables is modeled by the regression equation y equals ax plus b. Write down the value of a and b. So that's for a. For b is asking, hence, estimate the weight of a man whose height is 172 centimeters. Bearing in mind that height is your independent variable and weight is your dependent variable. For C asks, write down the correlation coefficient. Bear in mind that the R value is simply the correlation coefficient, and those things are the same thing. Finally, 4D asks, state which two of the following describe the correlation between the values. Your options are strong, zero, positive, negative, nor correlation, and weak. Simply pick two of these. And that there is your one multiple part question that you need to do for homework. Pause the video and do that if you can, which you should. I hope you can. Now, the answers to these questions are following. For 4A, A should have equaled 0.486, while B should have been negative 12.41. For problem 4B, the answer should have been 71.182 kilograms. For question 4C, the value should have been 0.997. And for question 4D, the two words to describe the correlation between the variables should have been strong and positive. And that's it, folks. There you have it. Topic 5.4, Calculus, Semester 1 video project by Elijah Wall. I hope you learned something. I know I learned something, and, second chances are always nice. So everybody have a day. Hit that like button. If you want to be a Patreon, never mind. Okay, goodbye.